Venus is one of the most extreme planets in our solar system, not because it has a strong magnetic field, but because it has none. Unlike Earth, which relies on a molten core dynamo, Venus lacks any internally generated magnetic field. As a result, the solar wind interacts directly with the planet's atmosphere above the ionosphere. When charged particles strike that upper layer, they induce electric currents that create a temporary, weak magnetic field. This induced magnetosphere forms a bow shock on the sunward side and stretches into a magnetotail behind the planet. But without an intrinsic field, everything depends entirely on the solar wind. When it fades, so does the magnetosphere. The ionopause and induced magnetosphere boundary define this region, where magnetic pressure balances ionospheric pressure. Field strengths can reach up to 40 nanoteslas in that magnetic barrier, but they vanish below the ionopause or without solar wind. Reconnection events and plasma waves occur in the tail, acting like the engine driving atmospheric escape. Ultimately, Venus's induced magnetosphere underscores how space weather can sculpt planetary environments in profound ways, even when a planet has no magnetized core of its own. True or false? Venus has a global magnetic field generated by its core. False. Venus does not have a natural magnetic dynamo. His magnetic field is induced by solar wind. What creates Venus's magnetosphere? Solar wind interaction. Fill in the blank. Venus's magnetic field is blank by the solar wind. Induced by the solar wind. Fill in the blank. The bow shock forms on the blank side of Venus. Sun facing. What mission first observed Venus's induced magnetosphere? Pioneer Venus Orbiter. If plasma waves traveled 240,000 kilometers along Venus's magnetotail at a speed of 600 kilometers per second, how long does it take? To find out how long it takes plasma waves to travel through Venus's magnetotail, we start with the formula. Time equals distance divided by speed. The total distance the waves travel is 240,000 kilometers, and they're moving at a speed of 600 kilometers per second. Now divide 240,000 kilometers by 600, and that gives us 400 seconds. But since we usually measure time in minutes, we divide 400 by 60 to convert it, which gives us 6.67 minutes. That means the entire journey through the magnetotail takes just over 6.5 minutes. Even without a natural magnetic field, Venus's induced tail can carry waves at incredible speeds over vast distances. True or false? Venus's magnetotail is formed by the solar wind stretching the induced field. True. Fill in the blank. Venus's rotation is blank compared to other planets. Retrograde compared to other planets. Why doesn't Venus have magnetic poles? It has no dipole field. Fill in the blank. The magnetic field strength can reach up to blank nanoteslas in the pile-up region. – 40 nanoteslas in the pile-up region. True or false? If the solar wind stopped, Venus would still have a magnetosphere. False. The induced magnetosphere only exists when solar wind is present. Solar wind moves at 450 meters per second and presses against Venus's atmosphere for 10 minutes. How far does it travel in that time? To calculate how far the solar wind travels as it presses against Venus's atmosphere, we use the formula: distance equals speed multiplied by time. The solar wind is moving at a speed of 450 meters per second, and the duration of this interaction is 10 minutes. First, convert 10 minutes into seconds. That gives us 600 seconds. Now multiply the speed, 450 meters per second, by 600 seconds. That equals 270,000 meters. Since there are 1,000 meters in a kilometer, we divide 270,000 by 1,000, and get 270 kilometers. So in just 10 minutes, the solar wind travels 270 kilometers while interacting with Venus's upper atmosphere and induced magnetic boundary. Which mission studied plasma waves in Venus's magnetotail? Venus Express. Fill in the blank. The layer where magnetic pressure balances ionospheric pressure is called the blank. Ionopause. A stream of charged particles travels 162,000 meters through Venus's magnetic pile-up region in 90 seconds. What is its average speed? To calculate the speed of a stream of charged particles moving through Venus's magnetic pile-up region, we use the formula: speed equals distance divided by time. In this case, the particles travel a total distance of 162,000 meters, and the journey takes 90 seconds. Now divide 162,000 meters by 90 seconds. That gives us a result of 1,800 meters per second. This means the particles are moving at an average speed of 1,800 meters every second, a rapid pace through one of the most compressed and turbulent areas in Venus's induced magnetosphere. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, Brainy friends.